I will also, oh, that's annoying. I guess I can't share a screen with you while I'm recording. But if you have like teammate, or you have SSH, I can just start teammate.
Cool.
Okay, so let's see. This will make my font bigger. Okay. So yeah, so I don't exactly know what we should do, but this was the test case, right? And if we look at the graph, I'm going to send you the gist. Oops, I guess well, whatever. If you look at the graph that comes out of it, you know, this has that work to kind of tag some of the region constraint edges as boring or interesting, but I realize I'm kind of assuming a lot of background that you may or may not have looked at that part of the code before. So like, first of all, how much do you know about the region numbers and the universal regions and all that stuff?
Off the top of my head now, not a lot.
Okay.
But I think I have read that about the book before.
Yeah. So the current setup anyway is that we have one universe, or one set of region numbers. For every region we give it a number. But actually you can see it in the mirror here in the screen on the right hand side. But for the first, there's like a prefix, and those are the universally bound regions. So basically the lifetime parameters on the function. And the tick 0, for example, is always static, tick static, because that's kind of in scope everywhere. And then coming after that, like tick 1, tick 2, and so on. And this, oh, your screen got a lot smaller.
I was just moving things around, sorry.
No, it's fine. It doesn't matter. But in the case of this function, then we have only 3. Let me open the function down here. But sometimes there might be more, right? What is this? Where is this output? Here it is. So the three lifetime parameters, what are they? Well, I don't know. I think they're, if this is the function we're analyzing, then there's an implicit sort of lifetime here. This is number 1. And then there's 1 here. That's 2. Right, so I suspect, is that right? I don't know. Well, oh, actually that's probably right. We could figure that out. In any case, it seems to have created 2. Oh, no, I'm wrong. I'm sorry. Actually, these are all 1 here. Or this is tick static. But, so there's some implicit lifetimes that were not written out in this signature. And by a lifetime elision, this one would be this one in the return value will be the same as the one in the input. So that's going to be 1. And then the object lifetime defaults make this bound be tick static. So that's saying like the data that That's basically bounding what regions can appear in the hidden type that the din trait is covering, if that makes sense. And the 1 is just, we just number them as we go, right? And you see that there are 3 free regions though. This tick 2 is another special one. So tick 0 is always tick static. Then there's a bunch of stuff that come from the signature, in this case just 1. And then tick 2, that's a special region that represents the function body, I think, like the whole function body, but I think. I have to double check that, but in any case, that's the idea. And so then all these other numbers, like 3, 4, 5, 6, 7, whatever, these are all variables that we created to represent intermediate regions in the mirror somewhere, right? So for example,
Wait, what was 1, did you say?
1 is going to be this lifetime, this kind of not written out explicitly, but it's in the signature.
Cool.
So like here.
Sure, okay.
If you had written it out, it would look like that. And I think, I'm pretty sure too, let's just take a quick look. So, oops, libra-c mirror, borrow check, universal regions. So where these things get, all these numbers actually get created here in the universal regions build method. And you see that we start out the first global index 0. So we start out with we've made no regions. Then we make static. That's the first thing we do. So basically the order in which we make these variables is the numbering they get assigned, right? And all this code is basically going through the signature, which is to say these types, the function signature, replacing the regions in there with mapping them to numbers is basically what this is doing. And then I think, is there one last? Yeah, so this one here, this line, FR, FN body, FR stands for free region. So the free region for the function body, that's number 2. And that's basically some special region that we make that is the function body. And it's just convenient to have a function. It's not really something the caller could name exactly, but it's convenient to have a region that represents the function body. And then we go and we add in relationships, like we say, for every free region that we just made, so 0, 1, and 2 in this case, we always know that 0 is bigger than it. That's what this line says.
Sure.
So we always know tick static is bigger than it. We always know that the function body is smaller than it. And finally, we always know that it's equal to itself. And then we also add some other relations that come. Like if the user wrote where tick A outlives tick B or something, that would end up getting added in there somewhere. So we have a kind of notion of how they relate to one another. And anyway, so that's the free regions. And then we have these inferred regions. And in the mirror dump, you can kind of see them all. And it's also giving you the values that we ultimately... So the mirror... It's also giving the values that we inferred for each of these regions, right? And so for each of the universal regions, we end up making, it's kind of a little weird, we end up making a variable that represents the universal region, like the lifetime parameter, inside the function body. And it's sort of saying what data, references with this lifetime, what kind of data flowed into them? How long did they have to live? And it has to be no longer than what the signature says. So, for example, if you had, or here, this is actually the bug. So here we have this tick 1, right? And that means, we said that is referring to these 2 regions in the signature. But we see that an element of it is tick 0. So that's saying that data which had the lifetime tick 1 was forced to live until the end of tick 0, which is tick static. And that's only okay if we know that tick 1 outlives tick static from these declared relationships. In this case, that's not true. And so that's why we're reporting an error, right? But it might happen if it weren't tick static, if it were like tick A and tick B, and we had something like this, and then we had like where tick A outlives tick B, then you might see this relationship where one of them has the value of the other, but it would be considered okay because there's a where clause that says that that's actually true. So that's kind of how it works. And so the idea is basically that we infer, what is the shortest lifetime that data with that region can live. Right? That's what these values are. And so here we're saying the shortest lifetime the data with region 1 can live is 0, and that's too long. And where we got this, how did we, like what was the basis on which we inferred this result? This is the final result, but where it came from is exactly those constraints that are dumped in this dot file. Right? And so this has edges between each of the regions labeled like R4 arrow R5. That means R4 had to outlive R5, I think. Is that what it means? It's probably what it means. Either it means that or it means the opposite. Let's look before I see if I can remember. The edge is, okay, no, I'm wrong. It means it's outlived by. If there's an edge from A to B, it means that, the B is outlived by A. And the reason for that is that it's kind of, basically it goes from the smaller one to the bigger one. And the reason is essentially any value that's in, the values kind of flow along the edges. So if you have the region A and it has an edge to the region B, then any points where A has to be live, B must also be live. It kind of flows across the edge. I don't know, I rendered it that way probably because that feels intuitive to me. More intuitive than the reverse direction. So unfortunately for the people watching on the video, if any, I can't show you. Oh, I can. That's not true. So yeah, if you look at the SVG, David, I'm going to move it. I have, and I'll move it over here. Sorry, I'm moving it, make it visible for the video. But you can kind of see the edges rendered graphically. And so in particular, we saw that tick 1, I said that the bug was that tick 1 has to outlive tick 0. That's why we were reporting an error, or the bug in the user's program, I mean. And you can see that that means that there should be a path from tick 0 kind of that reaches tick 1.
Okay.
And that, so this path is going to be like along here, coming down. So going from 0 to 13 to 9 to 16 to 7 to 17, then going over to 4 and then down to 18. And scroll, 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 and eventually you reach 1, right?
Cool.
And all the edges along that path, that set of edges is basically the basis by which we're going to tell the user why. Like one of those edges, or at least one, is wrong, right? Kind of. By wrong, I mean for the program to type check, the edge can't be there. And so the question is, what will it, which of those edges, how should we show to the user and explain and sort of say, you need to change something about this part of your program so that this edge is not there anymore, right? That's kind of our goal. And the idea of interesting was that the idea of cataloging things as interesting and boring was that I was trying to capture, like, these are edges where a lot of the edges that come in this graph basically just arise because of the way we desugar and other stuff that's not really in the user's control. So if we, for example, introduce a temporary value that has its own regions, then you're going to see an edge going out from the source value into the temporary and then out from the temporary into the final value. But the user doesn't know the temporary is even there, right? So we don't want to talk about it. But each of the each of the edges also has like a point associated with it, right, in the program. And we could possibly add even more data. I'm not sure if we're going to need it. So as an example, what was one of those? I think one of the interesting edges was BB4 of 2. So if we look for what point that is, that's here, which I guess you can see in the teammate session. So that's basically an unsized cast, which means we're casting, there's actually two of them, it's kind of interesting. There's one up here, BB3 of 0, and one BB4 of 2. So an unsized cast is when we create a trait object. And if you look at the graph we were looking at, you'll see that both BB4 of 2 and BB3 of 0 are on the path. So the data is flowing through those two casts. Right? And the first one is actually taking, if we look at _3, this is the one that takes the user's value of a known type, so a box of slice iter, and converts it into a box of like a din trait type, right? That's what this is. This is a din trait type. So this is kind of the one where we hide the type. And then this next one, I think this is an automatically inserted coercion. It's actually probably not a very interesting, despite being labeled as interesting, it's probably not very interesting. I'm going to do one thing that will help here. One of the annoying things about mirror dump is that it hides a lot of region data it thinks you're probably not interested in. But I'm kind of always interested in region data. So if you pass the -c verbose flag, then you get a lot more stuff in the mirror dump, particularly a lot more regions. And so we can see here that there's like these regions 8 and 9 and 6 and 7 and so on. So what I wanted to look at in particular, right, okay, one more thing. So, by the way, let me stop. Is everything I'm saying about these casts and so on making sense? I don't know if this is a corner of the language that you're familiar with. Okay, good. So I wanted to look at this cast. My belief is that we will not find this cast particularly interesting. And I think because we're going to find that the source type and the target type are kind of the same, or at least the regions involved are the same. So like, in this case, the source type is the type of _2, which is up here, which has region 15 and 16. And like 16R has this value. So that's the source value. But the target value is 9. That comes from down here. And we see that indeed they have exactly the same value. Right? So what I'm getting at here is this cast, I think, is basically a no-op. We didn't know it. Like the mirror doesn't, it turns out to be a no-op when you're done with inference. And thus is not very interesting to highlight to the user. The interesting case, and where the error actually comes from, is more like I think it's more this one, this cast, because this cast is the one that actually takes a type that is not an object, right, and relates it to an object type. And in particular, it's going to force this region bound 7 to have an edge relating to the regions in here, 17. And that's where the tick static kind of makes its way. So I guess what I'm saying is I can imagine a heuristic now, to step back a second, that walks along those paths and looks for interesting edges, and then we apply some additional tests that we couldn't do when we were generating the edges. And we say like, okay, this is an interesting edge, but looking at the actual source instruction, it's a cast. Casting, it's sort of a no-op cast. I'll just discard it. Or, oh, this is actually an interesting cast. And then we can report to the user something where we say, the algorithm I imagined would be something like, let me see, if this is the, right, this is the signature. Somehow, I don't quite know how. Let's see, what does it look like, first of all, without... if we take out borrow check equals mirror, this is the AST output. Which I consider to be ungreat, but it's a start, I guess. So I think we want something like, talking about this. So tick 1 came from here, right? I think we want to say something like, this data would have to have static lifetime. Not actually those words. Some phrase that means that. And then we can highlight from the function body, sort of. If we look at what the interesting points are, we will find one of them. Hopefully we can narrow it down to like the cast, which will have this span, I suspect. I don't know where we would want to put maybe we want to call this. So this, and we would say, casting this value to din iterator or something. The wording is going to be tricky, but I'm first most concerned about where do we get, and this will say source value starts here or something. And the idea would be first we pick some edge to be the primary. And so okay, we filter the edges to interesting ones. We pick some edge to be the primary point. This will just be a heuristic. So maybe we come up with, we should be able to say, for a given mirror statement, kind of categorize why it's interesting. And we already know that only, like if you look through, there's only so many kinds of statements that are interesting in the first place. Like assignments, call arguments, casts that I marked as interesting. So kind of categorize it, and maybe we have some heuristic that says like casts are more interesting than call arguments, which are more, just pick one, I don't know, we can always refine it. And then if there's more than one of the same category, we pick the closest one to one side or the other, right? Probably to the tick static, because that's like, that's the source of the contagion, I don't know. Or no, probably the other side, sorry. Probably we find the closest one to the smaller region because that's like the source of the data that then flowed into tick static somehow. I don't know. We pick one, that's the primary point. Then for each of those places, we put a label and describe sort of, maybe not even as specific as my label up there, but just kind of data flows here. I don't know. And then we put a label on the point in the source where the smaller region came from. So in particular, the universal region, like tick1, we find the argument in which it appears and underline those, saying data has to have static lifetime or something. And that would kind of yield, or I think I wrote source value starts here above. So modulo the precise wording, that should kind of give this display I'm talking about. That seems like a great start. I think there's this challenge that we've never figured out how to solve, which I'm also interested in trying to solve. And I think I'm tired of trying to find the best answer, and I'm wanting to just do some answer at this point, which is, how do we talk about things like this that don't have a name? And it's always kind of annoying. There have been some suggestions where we would basically make up names and then talk about them. And I think that might be the way to go. I don't know. Like, you could imagine something like fully elaborated type is ampersand tick1 t. Maybe we even use the numbers. I don't know. It's kind of weird, but they're not. We know they don't. We know that they're not syntax that the user could actually type, so that for plus or minus, they can't like shadow some other lifetime, right? And like this, casting this value to a din iterator requires tick1 to outlive tick static or something, right? So it might be confusing, but it seems a lot less confusing than the current AST output, or at least, let me rephrase that. It seems like something you could learn to read, and it tells you what's going on.
Yeah.
Whereas, this output is sort of, there's a lot there, and I guess you can learn to read it. I can usually extract some value out of it, but you have to like know how the compiler is implemented, which is a high bar. Anyway, so that's my vision. I think we could start by what I had hoped is, maybe if you have time, or me, or we could make a branch, maybe, I don't know. Start by pushing towards this first part, just having some labels. Maybe not even labels for end users, maybe just like this, source argument, interesting spot, cast, something like that, and kind of play around with that. That's already like 90. Once we have that, we're like 80% of the way there, I feel like, and it doesn't seem that hard to get there. And then we just have to do the other like 80% of figuring out the actual wording. But okay, my presentation is over. I don't know. Do you think that do you kind of see how we would get to this first point?
Yeah, I understand what it is we want. It's just whether I can map that onto the code
Right.
I see to figure out where it's actually, where I need to make the changes to make
I guess
it happen.
another alternative is I could try to push it to that first point. I get one way. Basically, one or the other of us should probably try to get it to that first point. But I imagine that if it were me, it might make sense, because I think I see how to get there pretty clearly. And I think maybe from that point, it's more obvious how to get these other, like it's.
I'd like to give it a go, because I think it'd be good to help figure
Okay.
out how it all works.
Well, I would like you to give it a go too, especially because because otherwise it'll take me forever. Just because I'm time splicing a lot of things. All right, so let's make that first thing be the goal. And I would say However, I mean, feel free to just throw questions at me, basically, obviously,
Sure.
in terms of if you don't know how to get the code there. But I think the thing to do, the function, the way I would just do it, the rough path I would start with is write some function that takes a location plus mirror and gives back like a constraint category, for lack of a better name, which is kind of saying what is happening here, something that you would explain to the user. And it can start out being very vague, like cast. That would be fine. It would. I think over time we're going to refine these to be more elaborate. Like we might say, well, so for example, I implicitly identified several things that were marked as interesting that I didn't think were that interesting. One of them was the no-op cast. Another one was the call to box is marked as interesting, but I don't consider it very interesting because I happen to know that box new is sort of a it's a dummy function, so to speak. Not dummy, but it takes a t and it gives back a box of t. It doesn't like add any lifetime constraints of its own, right? And I think we could figure that out fairly easily, but it's probably not worth it for the first version, right? We should just categorize that as an interesting call. Both the casts look interesting, and so then we'll wind up, if we do that, we'll wind up with a much busier chart that has like probably, depending how we do it, but that has several labels, kind of all in the same spot here, I guess. But and that's fine, right? We can refine that. So write some function that does this. Write some semi-arbitrary ordering on constraint categories to pick the master one. And then write code to find the argument, if any, that contains the universal region. We actually have some of this code. I have to look, but there's this part of the code called libracy infer region error reporting. Nice region error. There we go. And it has a bunch of stuff, which we might or might not want to reuse. Probably not. But for example, it has this function find arg with region. But it's all kind of here based. I don't know, it could work. Actually. I think what this function does, there's a comment there, but if I recall what it does is it tries to find the argument that references, oh, I know why we probably don't want to use this function, but I'll come back to that. It tries to find the argument that references the region, and then it gives you back some information about that argument, and in particular it gives you back a modified type that uses some other region that you said. And it's part of this other error where we're saying like, we're suggesting, and we could do that here too, maybe we want to. Maybe you want to put tick static there, basically. So our suggestion is like, maybe change this to and tick static t. And so for that we want to kind of replace the region with something else. But I'm not sure, it doesn't seem like a very good suggestion here, although it might be. I don't know, it's hard to tell. The hard part with region errors often is it's not really clear there are many ways one might fix it. They may or may not be correct. But in any case, the danger of using this, I realize now, is that we probably could, but it's just going to be a little tricky, because the types in the here are expressed in terms of, we've kind of renumbered them all to these region numbers, but the original types in the here that this is going to search through are actually expressed in terms of other region variants. And I think we have a mapping. We have a mapping in the universal regions. Where is it? Somewhere, unless I removed it. Or maybe it's in region vid, region infer mod. Oh yeah, external name. So this external name field, which probably there's a way to access. Well, it's not publicly accessible, but we could, well, actually, I don't even know where, we could add an accessor or something. But I guess we call it to-arrow region. Never mind, it is accessible. So we'd have to convert things into the other regions, but that's okay. I don't know. Anyway, we either use that or rewrite it and make the labels. And I guess actually step 3 is sort of, we could even do this in another phase. Right? The most exciting part is this part. And finding the argument where the region appears is like secondary. And the worst part is it might not even be an argument, so there are a bunch of edge cases. Like it might be only an aware clause or something.
Right.
So yeah, that's how I would do it. Maybe that's enough to get you kind of in the right general direction. Cool. This actually turned out to be a pretty good overview of some of the region's stuff. So maybe I will post it after all.
Yeah.
But well, is there more questions, or should we leave it there? All right.
No, I think that makes sense.
Cool. Talk to you later then.
See.